Hello juniors, this is electronic assignment number 14. We're going to cover the topic transforming functions. So basically what we're going to be studying today is the different types of transformations that any type of function may undergo. Okay? So the objective for this class is to understand the different types of transformation of graphs. So we're going to mainly cover three types of transformations which are covered in the IB program, which are translations, reflections, and stretches. We're going to try to understand what each of these transformations mean by looking at an example I prepared using the application Desmos. So this is the example. Imagine we have the parent function of a quadratic function, which is the red function you see in the graph, y equals x squared, okay? To the left, you may see all of the different functions that I'm going to graph. And to the right, you're going to see the actual graph of each of these functions. Okay, so the red function is a parent function for a parabola, right? It has its axis, its vertex, at point 0, 0. It's a happy face because the coefficient in front of the x squared is a positive number. And that's it, okay? So, what do you think the second graph will look like if I graph the function number 2, which is x squared plus 2? What do you think should happen? If I graph this, you'll see that we get the blue graph over there, which is the same function as the red one, but it is translated 2 units upward, okay? So you see that when we get positive 2 or plus 2, the function moves 2 units upward, okay? Now, what do you think should happen for function number 3, where we have x plus 2 squared? When we have the plus 2 inside the parentheses with the x. If you see this graph, you're going to see that the function moves 2 units to the left, right? So that sounds a little bit counterintuitive. We're going to see that in a while. But when we add plus 2 inside the parentheses, the function actually moves left instead of moving right, okay? So pay attention to that. That's also a translation. For the first case, the blue function, we call that a vertical translation, 2 units upward. And for the second case, the green function, we call that a horizontal translation, 2 units to the left. Okay, what do you think should happen if I graph? I'm gonna erase the other two just for a second. What do you think should occur when I graph function number 4, negative x squared? What you're gonna see is the following graph in purple. This is called a reflection. You see that the x-axis acts like a mirror over there, and we get the same quadratic function, but going in the opposite direction, okay? It's a reflection with respect to the x-axis. The x-axis is the mirror in this case. Okay, so that's what we call a reflection on the x-axis. Then, let's erase this one. What do you think should happen if when I plot function number 5, which is minus x plus 2 squared? I'm gonna graph this one over here just for you to see the difference. If I graph this function, we're gonna get this mirror over here. In this case, we're having a reflection, but a reflection with respect to the y-axis. In this case, the y-axis is acting like the mirror, okay? So we have two types of reflection on the x-axis, which was this case with respect to the red one, and with respect to the y-axis, which is the green function versus the black function, okay? So the y-axis acts like a mirror in this case. Then, going back to the parent function, what do you think should happen for the sixth function where we have 3x squared? Pay attention, we're gonna get something like this. The dashed red function represents this transformation, which we call a stretch, a vertical stretch in this case, okay? So if you see the graph looks more compressed than the original function, and all of all of the values of y are tripled. We're gonna see that in a while, but if you look, let's see if we may identify, if you go to the point x equals -1, for example, you'll see that the red function is in 1, and for the red dashed function for x1, we should be at x equals 3. You see that? We're gonna do some examples later on in order to practice this concept. But this is called a vertical stretch, okay? And finally, for the last case, function number 7, I'm gonna graph this, and we get this blue dashed function, 3x squared. This is called a horizontal stretch, okay? And as example number 6, this also causes a compression of the original parent function, okay? So these are all the different types of transformations. Translations, which are these two over here. Then we have reflections, which are these two over here. Let me grab this one. And finally, we have horizontal or vertical stretches, okay? Which are in this case. These are all the different types of transformations we have and that we're gonna study for the IB.